Also, hello to everybody from our side. We will talk a little bit about our experience doing the CKAD exam. But first, the agenda for the talk. First, a short introduction about us. Then some information about the general structure of the exam. Then we will go over all the topics that are part of the curriculum of the exam. And at the end, we will give you some tips how to prepare for the exam. And at the end, we also give our opinion, what we think about the exam after doing it. But first, to us, my name is Florian Fromm. I'm a cloud and DevOps consultant at Pexon. And Carsten, would you also introduce yourself?
Yeah, sure. Yeah, also hello from my side, Carsten here. A brief overview to my person. I have studied computer science at the Saarland University in Saarbrücken. My focus here was machine learning and NLP and computer vision. And since last year, I'm an IT consultant in Frankfurt am Main and colleague of Florian. I made my first steps in Kubernetes in a project in the automotive sector. Here we used a custom ETL solution using Argo workflows, a very cool workflow orchestration framework for Kubernetes. Maybe some of you guys know that. Yes, thanks for having us today. And I would hand back to Flo. He will give you some basic organizational information about the CKAD.
Yes, and also I should share some words about Pexon. So we are also a small consultancy startup, let's say, founded last year. We are currently 20 people, but we have so much work. We want to grow to 50 people till end of the year. So we are really looking for new colleagues. And if you like Kubernetes, you're probably a really good fit for us. So if you are interested, feel free to reach out to me. I'm also an HR manager at Pexon. Okay, but enough shady advertisement. Let's start. So first, it could be that you never heard of any Kubernetes certificates. So for these people, a short information regarding that. There are official certificates handed out from the Cloud Native Computing Foundation. They are free. We have the Certified Kubernetes Administrator. It is for the guy who operates and maintains the Kubernetes cluster itself. Then we have a pretty new one. I think they released that last year. It's the Certified Kubernetes Security Specialist. And I have not much information about it, but it seems to be obvious it's about security. And then we have the one we want to talk about today, the Certified Kubernetes Application Developer. And interesting side note for company people here or people who own a company, if you have 3 people with the CKA certificate, you can also claim the title Kubernetes Certified Service Provider from the Cloud Native Computing Foundation. Sadly, just for the 3 CKA people. But okay, back to the Certified Kubernetes Application Developer certificate. In the end, if you have the certificate, that just should prove that you are able to design, build, configure, and expose applications for Kubernetes. That means in the end, it addresses the guy who, let's say, deploys his application to Kubernetes and operates it there. It's not for the guy who maintains and operates the Kubernetes cluster. And there's also this distinction in the Kubernetes documentation. They always differentiate between the admin and the application developer. And that's the exam for the application developer, sorry. Okay, important question, what does it cost? Just $300, but you get 2 attempts. But the sad part is you don't get any real learning material. So you have to probably also buy that, but we will come back to that point later. And there's a good tip from our side. We also did that. If you attend KubeCon, I can't promise that to you, but at least till now, every year you could get a 50% off coupon at KubeCon. So even if you're not interested in KubeCon, but you should be interested in KubeCon because it's pretty cool. But even if you're not interested, you can save a lot of money by just attending and getting that 50% off coupon. Some meta information about the certificate exam itself. The scope of the thing is you get 4 clusters and 19 exercises on these 4 clusters. You have 2 hours time to do these exercises. And in the end, you have to score at least 66% of the total score to get the certificate, let's say. And that's also an important point you probably already see here. The hardest thing about the exam is the time pressure. It's really hard to get all 19 exercises done in these 2 hours, and also to have all the 19 exercises correct, let's say. But, oh yeah, sorry, one additional information. I wasn't sure where to put that, so I put it here. During the exam, you have one browser window where you have your, let's say, web-based shell, and you're allowed to just have one additional tab open. So they monitor your stuff. You have to install a plugin so the guys can spy on you. And that's obvious. The obvious choice here, the only sane choice, is to have additionally open the Kubernetes docs in the other tab, as a backup. Then another interesting thing is, at least if you compare the certificate to the Azure or AWS certificates, it's a practical exam. It's very different. That's not a multiple choice exam. You really have to do stuff on Kubernetes, and that means you really need Kubernetes knowledge, and you also need practical skills. I first have written there coding skills, but it's not true. You don't really have to be able to code or something like that. But you should be able to use Bash. You should be able to use Vim. It doesn't have to be Vim, but in the end, you are working in a shell, so you have to be able to edit text files in a shell. And yeah, Vim is an obvious choice, and it was also part of every tutorial I could find. And yeah, I also use Vim at work, so it was an obvious choice. And yeah, the best advice we can give directly at the beginning, you have to practice a lot to be sure to pass the exam. And the question could now be, okay, what to practice besides Bash and Vim? It's not that hard. Imperative Kubernetes commands are very, very important for the exam. So that could be an example exercise you get. So they tell you, hey, deploy a BuzzyBox pod, call it BuzzyPod. It should have set an env variable, and it should run command env. The thing is, you could now start to try to look through the Kubernetes documentation, but you won't find exactly that YAML definition you need. You could now start to copy different YAML definitions into each other, but that is very error prone, and you get really fast into big trouble. So you should use an imperative command, because with that command here, it could look a little bit scary to you if you've never seen something like that, but it's not that hard. You learn it really quick. You can generate this whole YAML you need, and there's not much chance to have any indentation errors or something like that. So, and it's fast, much faster than reading documentation. So in general, to pass that exam, you really need to practice and learn these imperative Kubernetes commands. Also, okay, the link is not that useful in the presentation, I know, but you can also Google for GitHub and CKAD exercises. It's a beautiful GitHub repo where they have listed a lot of these short exercises, and they also show you the imperative command to solve them. So it's very good for learning. And I now think I hand over to Carsten.
Yes, thank you. The scope of the CKAD is the interaction with an existing cluster. You are not supposed to configure a cluster or initialize. You only need to create and adjust Kubernetes objects. These are in particular pods and deployments, services. You need to know how to enrich pods with config maps and secrets. And of course, that is a very important topic here. You definitely need to work with persistent volumes and persistent volume claims. Next slide, please. This is the official topic distribution by the foundation. Given that, you can more or less predict what concepts are important here. That means you will see single container pods, multi-container pods, networking through the cluster, and as I said, state persistence. This is very important. And in the following, I will guide you through some sample questions for each of those topics here. I hope it's not too long-winded or boring for you guys, but I hope I can give you a feeling of the complexity of these tasks. So Flo, next slide, please. Yeah, one important note here, Florian has mentioned it before. You only have 2 hours to complete the entire exam. It sounds much, but it isn't. You really need that time. So you want to make sure that you are quick and you can solve these exercises very quickly. So the very, very, very first thing you should do once you enter the cluster, just 2 commands here: create one alias to shorten your kubectl base command to 1 letter, which saves you some second here. And another one, which I will present later on, is create an environment variable do, which basically means this is a suffix for some creation commands for Kubernetes. With that command, you can just create an object without deploying it to the cluster. This is this dry run client part here. And on the other side, you want your code in YAML file. We will see that later on. You need that to create a YAML file representing your object you want to create. And after that, you can enter that file with Vim, and then you can adjust some last steps before you deploy your objects. Good, then we are done. Let's dive into these questions here. This could be the first question in your example, in your exam here. This is very straightforward. It just says, dear user, list all namespaces in the cluster and save this list in that file here. Next slide. And you can just basically type kubectl, get my namespaces, and redirect that output list into my file they have specified for you. And this is basically it. This could be a first exercise. Get your points, do not make mistakes here, and you can head to the next question. And then you will definitely see something like that where you have to just create a pod here. The first thing you have to do, read that description of your tasks very carefully. And one additional boni here, you have a notepad in your exam environment. Take some notes, just add all the information you need, and then you can start. In this scenario, we just need to create a pod with Alpine in the default namespace. This is a good point. Always double check your namespace. You have to work in different namespaces. It's obvious for obvious reasons. They want to have to let you have a good overview over your objects in these namespaces. So they are partitioning the objects between those namespaces, and always make sure you work in the correct one, because it would be very, very annoying if you deploy an object in the wrong namespace. Yeah, here we have to create a pod called pod1 with a container called pod1 container and an Alpine image. After that, you just need to write a script that outputs the state of this pod. So let's go on. Flo, next slide. As Flo said, I can't emphasize this enough, and I will repeat that later on in the talk. Do not write a YAML file from scratch. You won't have time for that, and it's the chances making errors, like indentation errors in a YAML file, are too high. Just use imperative commands here. And an example would be kubectl run, then a pod1, this is the name of the pod, with an Alpine image. And then we take our environment variable do, which say make a dry run, do not deploy it, and output all the specification in a YAML format. And then we redirect it to a file which we will create. Then, Flo, next slide, we can open that file. And this is the fantastic thing about imperative commands. You have everything you need. Kubernetes provides you all you need for that. There is no need to create a YAML file on your own. So just go along and change the container name, which is the only thing that is missing here. By default, Kubernetes names the container the same way as the pod. That means by default, it is pod1, it's named pod1. So just add the minus container here and you're good to go. Next slide. Please do not forget to deploy your objects. It would be extremely annoying if you did your work, you created your YAML file, and then you forget to deploy your object. Just do a create, do not forget that. Then for double check, you can just say, could you please go to the last slide? We just have a look at our pods and see, okay, it is up and running, and then let's rush to the next exercise. Next slide. Yeah. And one additional remark here, the tasks invites you to create a shell script. So this is important here. Flo has said it. You need to be able to work with the bash. So don't be surprised if you see something like that, something that is off-road of the Kubernetes tasks. Don't be surprised. It's just an easy task. Create a shell script and just put a command in here which gets the description of your pod1 and just grab for the status. Next slide. Then you have something like that, when you execute your shell script. So don't be surprised if the task wants you to do something like that, some Unix stuff. It's not very hard, and yeah, then we can go on to the next exercise. Yeah, that's it about the core concepts. Now we go to the configuration part. I think it's very likely that you have to do something with configuration. To be honest, for me, it was always a bit of a pain in the ass to work with config maps. But once I have seen the beauty of imperative commands, everything has changed. In this scenario here, we are working on the namespace moon. We have a deployment called webmoon. And there is something going on here. There was some error because it seems that the deployment was not correctly configured. And so they want you to create a config map to solve the problem. Next slide, please. If you have a look at one of the pods from the replica set of the deployment, if you pick one out and have a look at it, then we see, okay, it seems that the config map was not mounted properly. So we have the evidence that this config map is not present in the cluster. So we need to make sure that it is. Next slide. And again, we use imperative commands. Do not forget your namespace moon here. We have as namespaces, we have the planets of our solar system. We are at the moon namespace now, and we create a config map. And we are supposed to create a key called index.html with the content of the file located at opt course 15, etc., etc. And the good thing about that imperative command is you can just say, dear config map, I want my key here, and as the value for that key, I want the content of that file. If you would not use imperative commands here, you would need to copy and paste what is inside of that file, and you will definitely don't want to do that, because that can really be a pain in the ass if you work with Vim. So just make sure that you use something like that. The same thing works for secrets, I guess, or you can add some literals here and give the value directly to the command line. It's very, very easy. And if you work with secrets or config maps, you definitely want to use imperative commands here. So next slide. And then this outputs you something like that. And imagine you would have write that on your own. You don't want that. You don't have time for that. So just use the imperative command. Next slide. Yeah, then to double check, you do not need to do that, but for practice purpose, it's always a good idea to create a temporary pod where you just want to see whether your pods from the deployments are accessible. So just make a temporary pod with an wait a second, I've got something in with an Alpine curler, just add your IP address from your pod. And as you can see, now the deployment is up and running. We can access our web server. We see webmoon web page. So everything is great. Now we can go on. Next slide, please. This was it about configuration. And I hope you can see these tasks are not difficult. You need to know what you do here. You need to practice and you need to be fast, but they are not difficult. Definitely not. Next topic, multi-container pods. It's very likely that you see something like that. I don't want to lose too much words about it because they are very obvious. You need to create a pod with multiple containers. In most of the cases, these are two, one main container and one sidecar container. In this example, we have a BusyBox pod with a command here, which just executes every 5 seconds, hi, I'm from main container, and redirects that output to a file, and do this again and again. On the sidecar container is just another container with exposed on port 80 with an empty directory as a volume and some additional information. I won't go too deep into that. Next slide, please. So unfortunately, it's not possible to create, for my knowledge, it's not possible to create multi-container pods with an imperative command. So just create one with one container, then we can adjust the YAML file. Flo, could you go to the next slide? Here we can just copy paste our container specification for the main container and add some information to the sidecar container. So one advice from my side, it is very, very useful to know how to copy and paste and delete stuff in Vim. It's not difficult. You just need to Google it one time and then you know how to do that. And it can save you minutes in that axiom when you know how to copy and paste stuff in these files. So just use a multi-container pod with one main container, one sidecar container, and you're good to go. Then you deploy your object and you're done. Yeah, thanks. Next one. It's very likely that you see something like readiness probes and liveness probes. Next one, please. In this case, you have to add a readiness probe to your container, to your pod. Here you need to create a new pod called pod 6 in the default namespace with that given image here. And for a readiness probe, you should execute cut, temp, and ready. And you should wait you should wait in the first place, you should wait 5 seconds, and then you should execute it again and again every 10 seconds. And this is basically your readiness probe. And we have seen that. Next slide, please. You can just create a pod with an imperative command here. You can give all the information that is needed. And then you can adapt your YAML file. And as you can see, you see these commands at the bottom of this file here. Just add the readiness probe. Flo has said we have one additional tab for the documentation. So if you are not sure about readiness probes and what exactly is required here, just have a look at the documentation, copy that stuff, paste it in very quickly, and then you can add a readiness probe to your pod. After that, you can just deploy your pod to your cluster and you're done with this exercise. So you see, it's not a big deal here. Then we can double check whether our pod was deployed correctly. And then we see the ready counter increments to 1. The pod is up and running. And this is the best thing you can see in the axiom. Then you know you can go to the next exercise here. Yeah, pod design, this basically covers deployments. You will definitely see something like something related to deployment, rolling updates, or rollbacks. In this exercise, we already have a deployment called API new C32 in the Neptune namespace. And it seems like there was something incorrectly. If you go to the next slide, Flo, to the next slide, please. Then you see that you have in your history some rollouts here. You have 4 rollouts. This is always a good idea to have a look at your history of the deployment, and you see that you have changed the image in your deployment or some other attribute 4 times, and that you can see in your history here. Next slide. Unfortunately, the latest update of the deployment created some error here. And if we pick out one of the pods, this is very essential here. You need to have a look at the replica set. You need to see your pods, pick one out, and then you see, oops, there seems to be an image pullback off. So something is wrong with that image here. And in this exercise, it was the case that you just need to revert the latest change that you to redo the latest update to the image to go to another version. In this case, I don't know, there was, I think, a typo in the image, I think. And once you have rollout, you have undone your rollout, you have done your rollback here, then you see all 3 pods from your deployments are up and running and you're good to go. In most of the cases, it's something like that. Some typo in the image, maybe you need to correct that, or you need to revert your rollout. So this is easy. Next one. Yeah, then we are almost done with the axiom. Another important topic are services. Next slide. For this exercise, you need to create a service and you need to create a pod. And that pod is supposed to be exposed by that service. This is basically it. It's very likely that you will see something like that in the axiom here. So don't bother with the details here. I will give you a brief introduction what to do here. Next slide, please. first of all, we need a pod. And as you might have seen that before, we just can use imperative commands in the Pluto namespace. The project PLT 6cc API is the name of our pod, and we use an Alpine, an Nginx Alpine image for that. And what is very cool about that, we can provide some labels here. There is no need to adjust our YAML files for that. We can just provide our labels in that imperative command. So once our pod is up and running, and this is the YAML file, and imagine you would have the pain to write it in the exam. You don't have the time for that, so don't use that. Learn these imperative commands by heart, and you're good to go. Next slide. Then we need to expose our pod by in service, and there are multiple ways to do that. The easiest way, since we only have one pod here, is to say, I want to expose my pod with the name, etc., etc., with a service called project PLT 6cc service on port 3333, and my target port of the pod is 80. And that's it. This is basically the solution for this exercise. Another way to do this is to create a pod service on its own, but this has the drawback that, of course, maybe some of you know that, if you create a pod like that, you need to adjust the selectors of that service, because for now the service does not know which two pods to cover, so you need to adjust the selector here. If you do the first solution, this is the easiest one, but you can also do it as well. If you know what you do, just do it like that, it's fine. And then I always recommend to do that in the exam. If you work with services or you just fix some problem with networking, always have a look at your endpoints. Don't forget your namespace. We are on the Pluto namespace here. And there you can get your endpoints, and you can see our service has one endpoint with port 80. So everything is good to go. The service exposes our pod. So this is our proof. We can go on here. Yeah, and then we are almost done. Very likely the last exercise of the exam will be something with state persistence. You can absolutely sure about that. So we don't go into the deep details. I just added these texts here just to let you know what scope the descriptions of these tasks look like. So what do we have to do? First, we create a persistent volume in the earth namespace, I think. No, persistent volumes are not bounded to namespaces, so we can leave that information away. And always make sure that you have the right properties of that object. That means in this case, you need a capacity of 2GI. The access mode is always read write once. You won't see any difference, but you need to provide that information and your host path here. Then you need to create a persistent volume claim. This needs the information of a namespace here. And this information for the persistent volume claim should comply with the persistent volume. And after that, you need to create a deployment which mounts this persistent volume. So how can we do that? And Flo, next slide. And here it is very important that that you be aware of one thing. For the time being, it's not possible to create persistent volumes or persistent volume claims with imperative commands. I don't know why this is why this is the case. Maybe there is some advanced reason for that. I don't understand. But for that, you are not able to provide imperative command. So since Flo has said that before, you have the opportunity to open one additional tab with the Kubernetes documentation in it. And there you can just search for the persistent volume. Maybe you can just bookmark them beforehand, then you can access them very quickly. And then you just can copy and paste that template you find in the documentation here. Paste it in your YAML file, adapt the information, delete unnecessary stuff, and you're good to go. Again, do not write YAML files from scratch. It takes too much time, and especially for this amount of information, just copy and paste for persistent volume. Next slide, please. And the same holds for persistent volume claims. Just copy the template from the documentation, paste it in here, and you're good to go. I did it the same way. And to be honest, I would definitely not have enough time to do that. After that, as a little checkup, you can just get the information for your PV on your PVC. And if you see something like bound, you can be very happy because that means that your persistent volume is bounded to your persistent volume claim. And so everything runs smoothly. For the last exercise, remember, you need to create a deployment where you need to mount that volume, that persistent volume claim. So again, it's always the same story. Write a imperative command to create a deployment and redirect that YAML information to that file because you need to adapt this file. You don't have the mounting information yet, and you want to alter it. So here you see that comments here with the add. You need some volume information to your pod template here. You need to provide the information where to find it. In this case, it's the name of the persistent volume claim. And of course, you need to mount that persistent volume claim to your container here. And this can be done with the volume mounts directive, with the name data here. And in the best case, everything works smoothly and you can start your deployment. So next slide, please. And that's it. This is basically the whole coverage of the CKAD. You see the task, if you practice, the task won't be difficult. The only problem, as Flo mentioned before, is the time boxing here. You need to be fast, you need to be quick, you need to be, you have to know your imperative commands by heart because you won't have the possibility to take them with you in the exam, but it's not a big deal. So next one are a couple of words about the debugging. Often you have the task to repair something in the Kubernetes cluster. And for that, I give you some advices, which you can, I don't know, screenshot or something. The first thing is a good idea to get a list of all your namespaces. Where can be objects? Then list all your pods. This is the key here. List all your pods, in the best case, in all your namespaces, because then you can just have a look at the status of different pods. And if you see something like image pulled back off or error, or I don't know, something like that, then you know, okay, there has to be the problem, and then I can investigate further. Then if you have located your corrupted pod, you can get the description of it. Maybe there is some event which tells you something about the error, or as an alternative, you can just have a look at the logs of a specific pod. Yeah, container, sorry. Next one, change pods. Sometimes you have to change pods. For some properties of a pod, you can just edit the YAML file, but sometimes this is not possible. So you need to create a completely new pod for that. So this is my recipe for that. Just get the information of that pod, the specification, and output in YAML format and redirect that information to a file. You definitely don't want to lose the pod here, because once it is gone, the only possibility here is to restart your cluster, and this is not a good idea. So just save it to be safe here in a YAML file, and then you can delete your old pod, alter the information in your mypod.yaml, and you can deploy it again. So you're good to go. And as a final word, next one, please. Sometimes you have to deal with, I had to do that in my exam, to troubleshoot access issues. Maybe you have something like a network policy, you have some pods here, and because of some reasons, pods don't have access to something, or they should have, or they shouldn't have access to something, and we want to block that. In these cases, I'm absolutely sure you have two scenarios here. The one is that the pod is missing some labels, that you need to provide some labels such that the network policy allows the pod to access something else. Or you need to reconfigure your network policy where you add some ingress or add some egress to make sure that your pods have access to any other resource which is restricted here. So this is it about debugging. You will definitely make use of these tools here to walk properly through the cluster here. So thanks. Next slide, I think I can hand over to Flo. He will give you some advice for the preparation.
So first, could please the co-host who scribbled on the slides, please try to remove that again, because I don't know how, and I don't think I can do that. So first, regarding learning material, like I said, you don't really get great material from the CNCF itself. So there are two famous courses, one on Udemy, one on Linux Academy. They are both good. They teach you in about, I don't know, 8 hours of video material, the theoretical basics. But what's more important, they also give you some training labs where you have a very similar environment to the real exam, and you can practice some smaller exercises. And you can do that as often as you want. That's really nice about them. Then, yeah, Carsten already mentioned that. That's something very basic, which every tutorial for the CKAD exam tells you. Just create bookmarks for every topic that is relevant for the exam itself. Because you're just allowed to use one tab, but you can have bookmarks in that tab. That's no problem. So that also saves you a lot of time. Then there are two special parts of the Kubernetes documentation which are really, really helpful during the exercise or the exams. First, the API documentation. Here you can look up for each existing Kubernetes objects, how are the fields called if you forget them. For example, here are all the K8s objects. You can find everything that you can deploy via YAML here. And here you find, for example, the container definition has a field called command, and it's an array of strings. So you find the name and the type if you can't remember that. Or what's even better, for example, the readinessProbe, it's not just a simple value that's itself a complex object. You can also find a link here that leads you to the next description of this readinessProbe object, where you have each field of the readinessProbe object. So if you can't remember one field name, you can easily find that in that documentation. But it's costly from a time perspective. So this is really good during preparation, but I wouldn't use it that much during the exam itself, because you probably don't have the time. The CLI documentation, that's really like cheating. I really like that. First, you can find here every existing kubectl command. So the thing is, it's enough to know most of the commands that are relevant for the exam. You don't have to know everything about the command, and especially the imperative command, because, so here in the middle, you have some close-up description of the different flags for the command. But the cheating part, and it's not cheating, it's completely allowed because it's part of the Kubernetes documentation. You have here example imperative commands. And for a lot of the easier and smaller exercises, you find the correct command already prepared here. So you just have to copy that and change, let's say, the name of the deployment or of some flag. But in general, you get the commands you need here. And even if you need more than that command does, you can just add the missing flag, and you are done in less than a minute with an exercise. And then, of course, like you probably realized now, even if you study really, really hard, it's not easy to really prepare without practical exercise. And some smart businessmen also realized that. And therefore, we have now two sites that provide exam simulators. So you can do a complete simulated CKAD or whatever exam here. That's the first one. It's called killer.sh. The thing is, that exam is a little bit harder than the real one. So you could be a little bit scared if you do it the first time, but it's a good preparation. It's a full 2-hour session like the real exam. So you have 2 hours and then shut off. You get also 2 simulator sessions for, I think, $30 or something like that. The only sad part here is they only have 1 exam. So it's, and also the example exercises Klaus showed you, they were copied from their 1 exam, for example. So you can do 2 times the same exam. It's not that useless because for the first time, you're probably not used to that. So you will miserably fail. You will be too slow. You won't get every exercise done. But later you also get a complete solution for each exercise. And then you can try it a second time and try to be as fast as possible to also be prepared for the real exam. And then there's another side. It's newer. It's the underdog of these simulators. It's called KubeWiz. And their difficulty is much closer to the real exam. They have also the idea, I talked a little bit to their sales guy, therefore I know that stuff. The idea is to have smaller sessions because most people don't have or don't want to spend 2 hours and then probably additional 2 hours to review their exam practice. So they offer smaller sessions so you don't need to spend the whole evening practicing. Then, yeah, you also get multiple of these smaller simulator sessions if you buy that. And the really nice part is similar to the real exam, they have randomly generated smaller sessions. So you get a random set of exercises, which is cool, I think. Yeah, that is about it. That are the 2 available simulators. And at the end, a short resume from our side. So what is our opinion about CKAD after doing it? So first, we both had the opinion it is hard but fair. The hard part is just the time limit. The exercises itself, there are no shady exercises that try to trick you into doing something wrong or something like that. They are really doable, but the time pressure is hard. It was really fun, especially if I compare that with that boring multiple choice exams you have to do for Azure or AWS. I really prefer these exams. I had really fun to prepare for the exam. I think Klaus also. And yeah, that's also my personal opinion from 2 sides. First, I think the certificate provides real value because if you're new to Kubernetes and want to prepare, for example, for a Kubernetes project, it's a really good idea to do this certificate. It will prepare you. But like I said, I'm also part of the HR department and I do a lot of technical interviews. And if one candidate would have that certificate, I would trust him to be able to work in a Kubernetes project. So it's also, for me, from an HR perspective, very interesting to see the certificate with candidates. Yeah, that's it. Any questions?
So I would, again, highlight, if you have questions, please raise your hand and we will pick you and ask you to ask the question through your microphone. So we can start with Ragul because he already raised his hand and I also have questions.
Okay.
So, Ragul, up to you.
Yeah, yes. Yeah, may I know what is the default path in President's volume path? It's like a where or which one? Where or log, which one I want to take? If you want
you meant which one you should start with, for example?
Yeah,
that's the CKAD. The CKAD is obviously the easiest one. The CKA is much harder. I also looked in the curriculum of the CKA. It's much bigger. And you also have to do things like bootstrap a Kubernetes cluster from bare metal and such things. So you probably don't have to do that during the exam, but you have to have the knowledge you need to do that. So I would suggest everybody to start with the CKAD.
Yeah, okay. Sure. It's if I'm using bare metal server or a physical server, I can add the from where default storage path, President volume.
Sorry, I don't get the question. What is with this storage pod?
The storage path, it's like it's in Docker where it will come.
Maybe you can write down the question, Ragul, because we have little issues understanding what you're meaning. Would it be possible to write it in the chat?
No, it's I'm doing partition from. Yeah, okay. So if you I'm doing partition from where and in disk level, so I want to allocate a where location only for 40 GB or something in storage. In if you Kuber going to install in offline in physical server, we are going to install Kubernetes in physical server. So where I want to choose the path in the where path or /where or anything.
You mean where to mount the storage
if
you want to deploy a MySQL pod?
Yeah. Where do you want mount?
I think you will find in the MySQL documentation where the, let's say, the data directory is, and there you should also mount your persistent volume to save that data or to not lose it if you lose the pod, if that's your question. But that's not a CKAD question, I would say.
May I ask, specify the question. Are you asking how to make persistent storage on a bare metal cluster work? Because I assume
Yes,
the
correct,
question goes to the
correct.
direction how to make it persistent in a distributed setup if you have no cloud provider backing, no block storage from cloud providers. And if that's your question, I assume you're aiming into the direction of stuff like Longhorn or storage or even node directory where you can save to a local directory of a node. But if you're not in a cloud setup, I believe it's a very different question to answer. Difficult question to answer, I'm sorry.
Yeah. Okay, got it.
Okay, so we have one question from the chat. I will read it out from Philip. He asks, how does the certificate help in your daily work and CKAD consulting projects?
Okay, the thing is, I worked before with K8, so I didn't learn that much, but I think it makes it just easier to apply for projects because you can tell the customer, hey, I have the certificate, I know what I do. I mean, you can always say I know what I do, but at least you now have a certificate to prove that.
Okay. And Nico is asking, what means the empty curly bracket in the YAML file?
The empty curly bracket. For empty dir, is it possible?
Maybe.
Yeah, I guess so.
Question from the chat.
I could be wrong, but I guess it's just a placeholder, right?
Yes, it's just because the best example I can remember is empty dir, because empty dir is an object, but it's an empty object, and therefore you put just the empty square brackets behind it as a value because it's an empty object. It's also part of YAML syntax.
Mm-hmm.
Okay, wait. I will give Nico the ability to talk, so maybe he can ask the question with a bit more context. So Nico, if you like, you can talk now. You don't have to, no problem. So I will give up to Bukola Johnson. She has a question too, and it's your turn now.
Hello, everyone.
Hello.
Hi.
Thank you for the session. Okay, my question is, I'm preparing for CKA, and my question is, it's not a technical question, it's just an environmental question. I would like to know, because I use Vodafone at home, and then sometimes, like almost every time, it disconnects, like I get disconnected. So I want to know, when you are doing the exam, what happens? Let's say your network goes off. What do you do?
You have a big problem, at least with the provider we did that with. So you could have a different provider to do the exam with, but in the, let's say, policy of our provider was written down, if you lose the connection during the exam, that's a fail point. So you have to have a stable internet connection.
Okay.
Wow. Okay.
And I think the problem with that is, I think that will be similar for each provider, because that would be an easy trick to cheat, to just say, oh, I lost the connection. Can I do a new one? So what else should they do?
True. Okay, I'll take note of that and find alternative, I guess. Thank you.
No problem.
You're welcome.
Okay, another one from the chat from Hamid. He asks how much time we need to get prepared for the exam.
It depends how hard you try. I think through the theoretical material you can get through in a weekend, but especially if you are not that used to this imperative command stuff, I would practice. I practiced 5 days, so every day of the week. It was a work day week, so I could just practice in the evening, but I practiced every evening, I don't know, 2 or 3 hours, and just did an example exam.
Mm-hmm. Yeah, I can guide you through my learning process. First, I did the course on Linux Academy, but you can also do the Udemy course. It doesn't make a difference because they are oriented on the topics of the CKAD. And once you are through, you will definitely need hands-on labs in these courses. But once you're through, then you can do the learning part, which is learning these imperative commands by heart, but it's not that hard. If you have practiced them again and again, you will definitely know them. And after that, just do a simulation 2 times and you are perfectly prepared for the exam. So yeah, I would agree with Flo. It's about a couple of days. It depends on your pre-knowledge. And yeah, I think a couple of days should be enough for that.
Okay, great. So I see Nico is finally available. Do you want to talk about the empty curly braces thingy? No?
Yeah, hello.
Oh, okay. Hi, Nico.
Hi.
Hi. Sorry. What I mean is not empty there. In YAML file you show there's a bracket, curly bracket, empty curly bracket. What exactly?
Do you have a page number, a slide number? Sorry, because then we
Why?
can look at it.
Okay, that might be difficult. We can't go back in time now.
Yeah.
But I believe he asks what is actually the meaning of empty braces. I believe it's just an empty YAML object, you know, just highlighting to Kubernetes that there is nothing more, just an empty object placeholder.
Yeah, like my match label, app project, earth flower, strategy, curly bracket, template, metadata, blah 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 blah.
If not, you can also whisper that or send that as a text message in the chat to me or Carsten. Then we can try to answer, because it's now pretty difficult for me to understand what exactly you mean.
You're also happily invited to join our Slack channel. I've posted the link a few times in the chat already, and we can always discuss this there. We also plan to upload the recording of this demo and of the talks, so maybe we can use that to reference what exactly you mean afterwards.
Okay.
Yeah, so we don't get out of schedule here. Another question from the chat is from Zoltan. She says, I'm sorry, if I'm not mistaken, the exam used to be 3 hours long and now it's just 2 hours. What do you think? Why did they do this change? And does it mean that the exam became harder?
That's not, I believe the CKA is 3 hours and the CKAD is 2 hours. I'm not sure if that changed over time. But it could also be that I'm mistaken, but I have in mind that the one is 3 hours, the other is 2 hours.
Okay, great. Another one from Ali. He asks which certification one should choose if he wants to automate the process integrating with DevOps. I believe he also aims for asking, deciding between CKAD and CKA.
It's hard. The best thing is probably you need both. But also one thing I realized, the curriculum of CKAD is mainly also part of CKA. CKA is just more content. So probably if you do CKA, you will have everything you need. Probably a little bit more, but.
Okay, I'm going through more questions. Guys, some of you are asking very specific questions towards the behavior of Kubernetes. I guess this is a little bit out of scope, but something we can surely discuss in the Slack channel where people can answer that. I will post the link again so every one of you knows what I'm talking about. You can join and re-ask all the Kubernetes specific questions that are not related to the talk directly. Also stuff like how to get discounts on the exams. I believe this depends mainly on if there are any discounts available at the moment. But yeah, CodeCloud and the Linux Foundation often offers discounted exam slots every few months. So going through a few more questions, but I believe that was it. And all questions I had have already been asked. So is there anything any one of you wants to know from Florian and Carsten? I'm sorry. Because if not, I would like to proceed and thank both of you for taking the time to enlighten us on the CKAD. I've started a poll in the meanwhile. And yeah, of all the people participating in the poll, 97% have not taken the CKAD exam, while 73 are planning to do it. And with Florian, Carsten, and maybe myself, you have, yeah, at least people you can ask for references or for help and how all this works. So giving back to Florian and Carsten,
Okay.
any final words?
I have a final last advertisement, but it's just a private one. I'm also organizer of a SaarMeetup called Rust Saar, where we discuss the programming language Rust. So if you're interested in that stuff, I would also be really happy to see you or if you give our meetup a try. It's monthly and every second Tuesday of the month at 6 p.m. That's it from my side. Thank you very much. Carsten?
Yeah, also from my side, thanks for having us. Thanks.
Okay. Thank you, guys.
Thank you.
That was awesome.
And also thank you, Fabian, for organizing that meetup. I think it's a great idea. We need that here in Saarland.
Yeah, I believe that too. And I hope we can make that an institution. So we are a little bit, we have a few road bumps ahead. I've mentioned that already. So our second speaker for today, the second talk from Mats Brossen about Kubernetes and WebAssembly will be postponed to the next meeting. I'm sorry for that. Mats unfortunately didn't make it into the meeting before it was full. And that's definitely my bad. We're working on that. So we are actually proceeding with our talk. If there are no questions left. And after that, we're actually done for the week, so we can prepare for the next meeting and make sure that happens in a better shape next time. So just give me a moment, starting that screen. So as mentioned, my name is Fabian. I'm from P3R. We are a small, let's say, boutique cloud native consulting and software strategy agency from Saarland, and we have a very operations heavy background. We're doing lots of things in the space of DevOps and cloud native software delivery and development, and our main focus is on helping startups finding a good tech stack and helping enterprises moving away from bad tech stacks. And all of this involves lots of DevOps, containers, Kubernetes, and of course, automation tooling. And today I want to put Kubernetes into a context for system administrators because, as mentioned, by heart, we're just that. We're building Kubernetes clusters from the ground up, so from bare metal. And today, for all the sysadmins of you and for all of those that are tasked with operating complex systems, be it in a cloud native or a bare metal context, I want to talk a little bit about how Kubernetes fits into the picture. And I see. Maybe Florian, you can put a link of the Rust meetup to the chat. Somebody asked for it.
Sure.
Regarding, more questions later. I'm sorry. So Kubernetes, sometimes called the operating system of the cloud. To me, as a systems administrator and operator, this actually is a very, very descriptive claim. You can take Kubernetes as an API for APIs. So whatever you've done in the past with manual actions can be automated from, I believe, from point zero on. In our daily work, we are building Kubernetes clusters from scratch. That means we're invoking we're invoking bare metal clusters as well as cloud clusters and automating all of that process with tooling like Terraform and Ansible. And of course, after that, are also tasked with deploying applications to Kubernetes. And that's the point where it starts feeling like an operating system. Florian and Carsten already talked a lot about the different parts of the CKAD axiom, where all of it was pretty much split down in the components an operating system has, like storage, networking, compute, and processing, scheduling, and all of these things. Kubernetes behaves exactly like this in a distributed context. And it sometimes feels like you're actually working with systemd on steroids on distributed cloud nodes. And in Kubernetes, as we've learned just from the last presentation, pretty much everything is an API. You're instrumenting it like an API, which for some of our system administrators might be a little bit off or a new thing. So you're instrumenting the system, you're telling what you want from it, saying, I want a pod running on that node with that specific configuration with so many replicas. That's just like multi-threading a process on a Linux system, And for operating systems or system administrators, where typically lots of manual actions is involved, Kubernetes might be a little bit complicated. Let's call it complicated. When everything is an API, you need to know the boundaries of the system, which you typically don't need in your in an operating system. You don't need to know how everything works. Not everything is involved. In Kubernetes, it's just like that. Of course, abstraction levels rise, and the developer or the end user, let's say the application operator or developer, doesn't need to know everything from top to bottom. But the operator, the guys building the Kubernetes clusters, still need to do that. And a main point of using Kubernetes for a system administrator is automation. All the neat little things you have to build yourself and account for yourself, like self-healing, centralized logging, centralized store of truth, secrets management, volumes management, whatever you've taken into account for your infrastructure, be it small or big, is something you've probably pieced together by using multiple tools or multiple technologies. In Kubernetes, that has been done for you. And you can simply take it as a huge automation engine, as a huge operating system, taking your commands and doing what you want from it. And whereas you before tried to, or often maybe, did manual actions on servers, at least in our daily work, manual actions on Kubernetes clusters, also using imperative commands, are typically, they don't exist. Imperative commands and commands we use against Kubernetes are typically ones getting logs, getting descriptions of pods, deployments, and objects in the Kubernetes API. But everything that has a right context where we change things to the system is automated from either an Ansible playbook, a Terraform thing, a scaffold project, or whatever. So the main point is writing down code to define a system like you want it to have and instruct Kubernetes to make it happen. And for a system administrator, this sounds often like, okay, sounds nice to have, but that doesn't work. In my experience of the last 2 to 3 years, it actually works better every day. Yes, Kubernetes is very complex and an operating system is very complex, but with each month, I believe, and each release they are yanking out, everything gets more sharpened. It works better, it gets more integrated, options increase, and the grade of automation you can achieve increases by a lot. And we're still talking about distributed operating systems. So you can have multiple nodes in multiple locations in the world still listening to one API and being controlled by one control plane. So automation for a system administrator, at least in my world of the past, was still a thing that was hard to achieve. You had to make many compromises. You needed to make many switches in architecture to actually make it happen. In Kubernetes, that's the main purpose, automating everything. And from a system administrator's point of view, things start to change in the way we work with it. So when before something goes down, we are jumping right into our Linux machine and start debugging and start restarting services, managing configuration on the machine and stuff like that. In today's world, we typically do a rollback to a version that worked. We just learned how that works by just changing pod commands. And then we start digging into the problem and automating a solution. So next time the problem arises, we can simply, push a button and it works again. So it's very important to approach this with an automation heavy mind and with the intention to not do too much manual work, because that will definitely interfere with the bigger system. Kubernetes is not built to run a single app. I mean, you can do it, but it's actually not built to do that. And if you're dealing with systems at that scale, everyone who did this will hear me, automation and having everything in code. And I mean, that's actually the point. Having everything in code and descriptive and declarative is actually one of the best ways to work in a team with distributed systems and still be able to move forward. Because that's what's often blocking system administrators moving their systems to a better direction. You have too many, old things to account for. Another thing with Kubernetes is scaling. Scaling is one of the things that's called out the most. Why you use Kubernetes for endless scale, infinite scale, which is actually a pretty cool thing, but also something most people don't really need. Horizontal auto-scaling of nodes and pods and all of that is pretty amazing, especially if it's load-based. But for the reality of people having to work with, on-premise infrastructures or smaller setups where you have a few web apps and not that 10,000 container microservice infrastructure, scaling is a different problem. You don't do it that often, you don't do it that fast. Still, Kubernetes helps with it because it's a built-in mechanism. While it might be very much harder to scale a Proxmox or VMware cluster, in Kubernetes is just like, okay, I hook up another node to the control plane and make sure it's like the last one. And once certain constraints are met, your cluster can grow and shrink anytime, and the control plane accounts for it and makes sure all your workloads are distributed. For system administrators, this might not be the one thing they are looking out for, but still something you should understand. You will scale in the end, your systems will grow, you will change them. And here's a system, Kubernetes is a system that accounts for this behavior from the start. It's not a, yeah, you got one node and look how far you go. So it's actually built to scale. And that should give you a very good feeling when running your workloads on it, because there's no glue code or no hacking and no maintenance to plan into your workflow, because you simply add more capacity and the system knows how to distribute your workloads to that capacity. Cloud services is a thing. You can use Kubernetes either with cloud services or as cloud service provider. One of the typical tasks is to use it in combination with cloud services. Kubernetes was once built to handle stateless workloads. That means it's not carrying data. So databases or volumes, as we've heard today, are kind of a new thing because containers haven't been built to actually provide that capacity. Still, Kubernetes integrates well with many cloud services in terms of networking, load balancing, block storage. So a Kubernetes cluster is simply a work scheduling machine, and it can be enriched with add-ons, plugins, and drivers to do more. For example, to mount volumes of block storage from your cloud provider into your pods, to provide you with a load balancer that routes ingress traffic into your cluster, or a web application firewall that you can put in front of it. And it also, of course, can integrate with the cloud providers to enable scaling up of nodes. On the other hand, for system administrators, again, Kubernetes is a very good target to run your own cloud on. You know, the cloud is just anyone else's computer, but in that terms, it's very easy to run stuff like GitLab, Harbor registries, I don't know, a WordPress blog in Kubernetes. People have figured that out already. You just Helm install something on a cluster and can be 99% sure it will work out of the box if you don't have too hard requirements. And as such, you can use Kubernetes and stuff you run in Kubernetes as a replacement or an enrichment for cloud services you also use. And as Kubernetes is a project of the Cloud Native Compute Foundation, everything moves into that direction. People are, I wouldn't say expected, but it moves into the direction where people don't have that much infrastructure at home anymore, on premise anymore. Still, we do. And there are legacy firms that have legacy infrastructure, and there are legacy sysadmins that are scared of Kubernetes. You don't have to. It's actually today, it's a solved problem. In a way, it's still very complicated. It's a beast. But as Carsten and Florian already pointed out, there's much of it covered. And it's pretty easy to get onboarded and to run very, very productive workloads on it in a short amount of time. And then, yeah, I don't know. Don't use that many cloud services anymore, or have your own cloud services infrastructure based upon Kubernetes. Basically, from a viewpoint of a sysadmin, that was our presentation. We don't want to dive too deep because I actually hoped for Mats to hold his presentation on WebAssembly. That would be a very nice addition to the CKAD in the realm of applications. And we're just approaching this from a sysadmin space point of view. We're saying Kubernetes is kind of the future. It's not the one thing that replaces everything, but it's definitely something you should look at if you're running infrastructure. Doesn't matter how complicated it is. Kubernetes won't certainly make it more complicated, probably just the other way around. Things get easier once you've understood it. So from my end, that was our very short talk on the topic of Kubernetes for sysadmins. And I'd like to get back to you if you have any questions regarding that. If I can see. So. Let me please go through the chat a little bit. Okay, well, no one has questions for that, which is fine. There are still some left for the CKAD. Florian, Carsten, you still there for a few questions?
Sure.
So someone mentioned all the exams are now 2 hours long. That's for one. And Amit, as a backend developer, asks which certification he should go for.
CKAD. Because I assume you want to deploy your, for example, microservices to Kubernetes, and that's exactly what CKAD is made for.
Okay, that's very good. Is there any limitation depending upon the cloud provider for Kubernetes? That's a good one. I believe there's some limitation, at least when it comes to ingress traffic and load balancers, because I think the not cloud implementation of load balancers is with Metal LB still in a beta phase, and anything related to ingress traffic works better in the cloud because you can simply request a cloud load balancer while you on-premise have to make it yourself. But I don't think that's a hard dependency. It's just something that works easier in the cloud. Besides that, I don't see anything depending where Kubernetes depends on the cloud. Okay, he says he also wants to extend Kubernetes with operators and custom resource definitions. That's great. I still think the CKAD is a good one, but maybe there's also room in the CKA or another one to learn more about operators and custom resource definitions. Since I have not taken it, Florian or Carsten, do you know?
I think they will release a 4th certificate next year for operators or something like that.
Okay. So besides Minikube, is there any others to test and deploy KADS in test environment? Of course there is. There is K3S, which I personally like very much. It's from Rancher or from Zeus as of now. There is Micro KADS from Ubuntu. And I'm not sure if there's anything quick also. I don't know. But that's the 3 distributions or the 3 toolings I know for quick and dirty testing of clusters. And my favorite is KADS, K3S. Comes as K3D, K3S, and Docker, which gives you a full cluster just in Docker. So for using KADS, we must be expert in Docker containers. No, you should not be an expert in Docker containers, but you should have a very good grasp on the concept of containers. Yes, it doesn't have to be Docker, just OCI compatible containers. You should know what they do. Do you agree with the statement, not all applications need to use or migration to Kubernetes? I totally agree. Not everything needs to migrate to Kubernetes. Not everything's worth migrating to Kubernetes. In the end, we might all migrate to Kubernetes. That depends on if it will eat the world or not. But no, it's no obligation, and definitely not for everybody, you know. It's still a distributed system and brings its own complexity. And sometimes it's totally okay to just upload something to an FTP server and make it run there. Yeah, we see K0S and a link to it. That's very nice. I didn't know that. And then, is there any certification for solution architect in the area of Kubernetes containerization? Yeah, what's the solution architect in that context, Prashant? And how do you compare Kubernetes with OpenShift? Florian, Carsten, any words to that?
I think OpenShift to me is more like the poor man version for Kubernetes. So if you don't want to spend so much time maintaining, configuring your cluster, you could switch to OpenShift, for example.
Yeah.
Yeah, on a high level perspective, OpenShift seems a little bit more user-friendly. Currently in my project, I'm working with both. Actually, we have a development environment running in Kubernetes, on vanilla Kubernetes, and QS and prod are on OpenShift. And from my high level perspective, I'm not the administrator, I'm just a user of it. I can say that OpenShift has some cool applications like a UI for that. You can have a look at your secrets in your UI, which comes very handy here.
Yes.
Also to address one previous question about everything on Kubernetes or eating the world, I think the biggest weak point of Kubernetes is that it is fucking complex, at least if you compare it with easy solutions from the big public cloud providers or something like OpenShift. And I think that's really a big downside to a lot of people.
I agree. It's very complex. And it's to get back to the OpenShift thingy, I also agree. From my point of view, OpenShift is kind of a platform product, platform as a service, so to say. where they wrap a lot of user-friendly tooling and UI around standard API stuff Kubernetes offers. And I believe before, in the past, they had their own Kubernetes-like workload distribution engine. And as far as I know, they are migrating to vanilla Kubernetes as their backend now. So OpenShift is just something on top of KAD in the future. Yeah, something like a platform or something like Heroku, where you can write manifest files and deploy full applications. I'm not sure. Definitely something to try and to have an eye on, because it's from Red Hat, and that's where the great support comes from. But still only an addition, I believe. And if you don't want to deal with the hardship of Kubernetes. So another question from Mohit. You should be able to unmute your microphone now, so to ask your question. Okay, maybe he decided otherwise. I believe that were all the questions from the chats. I've heard there are already questions in the Slack channel, which I will again post so everyone can join that's interested in discussion. Just a moment. And if no more questions arise, I actually would like to thank everybody for being here today and bringing us into the great position of not having enough room for more people. Thanks for all the interest. Thanks for everybody that made this possible. Definitely our speakers today, Carsten and Klaus from Pexon Consulting. Thanks for taking the time. Thanks for all the questions everybody asked. That was really enlightening. And also thanks to all my colleagues, partners, employees, and everybody who helped managing this. We are already in the making of making this better next time, dropping the 100 people limit and getting a better workflow. So stay tuned, and we will be back in 2 months, I assume. Remember, Florian has the Rust meetup. That's every month, and you're all invited to attend. Also, you're all invited to attend our Slack community so we can stay in touch and discuss about cloud native topics and Kubernetes, and maybe help some of you approach or even master the CKAD. So from that end, if you have any more questions, please don't hesitate, reach out to me directly, either on LinkedIn, I'm Fabian Peter, or via mail at info@p3r.one, or the Slack channel, or any of our speakers. Thanks also to Mats, who isn't here today, for the talk he wanted to give. This talk will happen next time. So next time we will hear Kubernetes and WebAssembly from Mats Brorsen of the University of Luxembourg. And we already have 2 other talks in the pipeline. Stay tuned, everybody. Thank you. I hope to see every one of you again next time. We will publish a recording of the video and audio of this meeting on our website, and I will inform everyone in the Meetup and the LinkedIn events so you can find the links. Thanks again. Bye-bye.
Thank you.
Thanks. Bye.